Hey everybody, it's Mr. Carr again. Today we're going to be looking at this 8-2 day 2, and that is going to be when we're looking at complex fractions with our different least common denominators. Well, basically we're looking at all just complex fractions. And like we did with complex fractions before, it is a fraction over a fraction. Okay. But the biggest thing about these is that we just need to make sure that we're just keeping track of everything. So for example, when we look at this one, if I just kind of ignore this bottom half and just focus on these. So I've got a least common denominator for A and B. Well, that's pretty straightforward. It's AB. Okay, it's one of each since there's nothing in common. To turn them into that, I'm going to multiply this by A, which means my numerator gets multiplied by A. This one's going to be multiplied by B, and that won't be multiplied by B. So for the top half of my complex fraction, it's going to look like this. It'll be 1 times B is B over AB plus 1 times A is A over AB. Okay. And then if I put those together into one fraction, I can just do it as, I'll just do A plus B over AB. That's as simple as I can get in my top half. Bottom half, I'll do the same thing. So if this is 1 over 1, my least common multiple here is B. So I'm just going to multiply this by B and this by B. So if I do that, I have 1 over B minus B over B. And then I can put these together as 1 minus B over B. Remember, this is a division problem, thanks to that division bar. So that means I'm going to rewrite this as a division problem. So I'm going to have A plus B over AB divided by 1 minus B over B, which if I'm dealing with our rational expressions, we're now going to turn into a multiplication by flipping their reciprocal. So I have A plus B over AB multiplied by B over 1 minus B. So from there, just like our other rational expressions, we're going to look for any kind of simplifying, cancel out common factors. I have B right here and B right here. Those cancel out. And that's actually it. So my final simplified version of this is A plus B over A times 1 minus B. It feels like it's a lot of steps, and it kind of can be at times, but for the most part, it's just keeping track of it as a really complicated division problem. Okay, so let's do another one. Yep, just one more example for this one. Still dealing with our complex fractions. So we have 2 over x minus 1. So again, I'm going to make that into a 1 over 1. So my least common denominator here between x and 1 is going to be x. So I multiply that by x and that by x. So this is going to become 2. I'm going to take a little bit of a shortcut. 2 minus x over x. Okay, that'll be a little bit quicker on that one. Down here, multiply this by x and this by y. So times x and times y. So my bottom half is going to be 1 times x is x minus 3y all over xy. From there, again, it's a division problem thanks to this fraction bar here. So I'm going to rewrite this as a division problem. So 2 minus x over x divided by x minus 3y over xy. And then I can turn that into a multiplication problem. So 2 minus x over x. Let's not use the x there. There's too many x's there. And then multiply by xy over x minus 3y. Okay, last thing I can do is cancel out any common factor. So that's going to be x and x. And that's it. So that becomes y times 2 minus x over x minus 3y. Okay, and again, that's as simple as we can get with our common denominators and our complex fractions. Okay, that is it for 8-2 day 2. Got a couple of problems you want to try out. Here's one if you want to pause it real quick. And here's another one you want to try if you want to pause that. Okay, but bottom line is with our complex fractions, just make sure you keep track of it as being, first of all, a fraction over a fraction, which is really just a fraction divided by a fraction. Okay, and then it just turns into our other rational expression properties then. All right, that's it for today. Take care, everybody.